Yeah, already started streaming. Oops. Hello, peoples. I was talking on Discord. Sorry. Well, Discord related to this stream. Yeah. But still, what are we going to do today? I don't know yet. Well, the FIXME that I wanted to fix. Roman, yeah, you should go to bed. That is a good plan, man. I should go to bed too. Well, in a couple of hours. Instead of continuing all night, you know. I think I was working on this FIXME here. This one. Remove code duplication. This also exists in add texture. So yes, I split up my window in two. So now you can see that here there is code, and that is also, well, also here. This is the end of the function add texture, and this is the end of the function add uniform buffer. I think the last thing I was doing was looking if there is more code that is duplicated. Of course, this call to request shader resource creation can also be done in the same place, but that's commented out anyway. This is slightly different. The reason is that the other one, so go down here and then up. The other one calls members, which returns a vector, and texture doesn't have members. So now to put this single pseudo member into a vector just to get the same interface. Yeah, but then again, you know, then I do the same thing anyway. Am I not? Yeah, well, below that anyway, then. So if we have even more that is duplicated, or the same anyway, then I think I might change this to return a vector as a single member. So what is above that here is this. Meep. Hello bar. Let's go Control W and then up with the K. What we have here is this. This is already top of the function, isn't it? No, not really. Shader resource set key to shader resource declaration, try and place declaration, and then we get a key and the shader resource pointer, which is gotten from, which is the same type and everything. And the insert mgls id to shader resource insert standard pair resource temp. Now that is somehow really different. Well, not really different, but it's, you know, ish, different-ish. I think that even the GLSLID full is just a part of base, right? No, we have to find it. How many of these things are there? I think this is the one. Texture.h. Oh, that's and also a texture specific. Yeah, this one, oh yeah, definitely. This one uses the ID full and this one just uses the ID. So maybe, yeah, It's almost code duplication, but not quite. Why is this on full? Okay, because all the textures are called texture, double colon, and then the actual name of the texture, and the uniform bar is the opposite. They have a unique name before the double colon, and then after that you get all the members of it. So this is just a prefix, and this is the whole thing. Otherwise, I cannot tell textures apart. Maybe I can also exaggerate it to try to avoid code duplication. If I really wanted to, I could morph it into one thing, but I'm not sure if that makes sense. Anyway, I'm gonna go look at what is above that. Now we get to the top. Add texture. Okay, so this one starts with this call to descriptor set key. That's part of the base anyway. And then we set here, set index into 0, and then if it's not empty, I'm setting it to get set index hint from the key. That's definitely different, it seems. Yeah, it's all just a tiny little bit different. Except then of course this part again. But well, it's using that, which came from the not duplicate code. Might as well just leave it all, and then the only thing that is duplicated is this if here. Yeah, what shall I say about it? You would say, I can put this into this function, but then the name of the function is definitely not correct anymore. This comment is utter nonsense. Shader resource is actually it's not. Yeah, well, instance of window class not true, but let's say shader source should, well, let's name it as it is, point to just a member, point to a member of the window class. That reads a lot better, I think. I don't see the thread safe stuff here yet though. Yeah, let's not talk about politics in general. And I'm not. I never said I was. I'm just saying that it is politics. Yeah, the thread safe pointer. I find it really a ridiculous remark, you know that, General 550. Have you even done any research on this topic? You just blah blah what the media tells you. Mindlessly repeated. Damn it. Request shader resource creation. I think I just have to get over it and add a new member function or something like that. What is this doing? Set indexing to shader resource declaration. So you're adding here is a shader input data. I don't get it. What is this? This is a pointer to the current class. It's storing a pointer to itself in a member of itself. This is I mean, by the time you have this, you already have this. What is this even doing? Add a shader resource declaration context. Oh wait, yeah, no, what? If that doesn't already, well, it wants to add this. Okay, I guess it creates one. So I didn't make one yet, and because that looks suspiciously like the same type. Oh, but it isn't. Oh, this is a context. This is declaration then, and this is the context. Okay. Yeah, it looks like it stores this, but in fact, it creates an object that points back to this as being the owner. So try in place uses this probably a map, standard map, and then try in place uses 2 arguments. The first one is well, multiple arguments, but the first one is then the key, and the rest of the arguments are the arguments of the constructor of the info or data part. So in this case, we have as type a standard map with a set index int as a key, and indeed a shader resource declaration context as the element, I'll call it. And then the shader resource declaration context takes a shader input data, which is then the owning shader input data, as the argument. So then this object points back to whoever owns it, as in the owner of the map. That's what we do here. So how can I describe that? Store. It's not a pointer. Create a as context for the set index int. Create and store context and a map with key set index int. If that doesn't already exist, is that a good description of what is happening? No. And then how should the function be called? Yep. I'm doing this more often. It's like caching it. So storing something in a map if it does not already exist. So if it is already in the map, I don't do anything. If it is not in a map, I create it and put it in a map. Many instances that is kind of a caching, though you have a lookup key. And then the map that I stored it in is kind of a cache. So then you can say, do I already have this? If so, then I use that. You know, that feels like a cache. But the whole thing that if it doesn't already exist, I mean, create and store if it doesn't already exist, that makes of very long function names. So I made up a new word for it, I think, which I'm using in more places in this code. And that is called realize. Realize. I mean, it took me an hour and lots of dictionaries and use of the thesaurus and stuff like that before I came up with it. But once I have it, you know, let's stick with it. This realize in this code, in this project means make sure that it exists. Create it if it does not exist. Shall you use an A? And this is a bit too much English maybe. Realize shader resource declaration context. Something like that. Okay, and then I have to pass whatever we need. This is going to be a member function of the same object. So we already have that. We do not have the hint. And it's just going to create it. So we have the rest. And then this is going to be that function. Which is a member function of shader input data. And we are passing the set index hint, which is defined as here it is, descriptor set index hint. And then it should work, right? Why does debug only not have a color? It's a CW debug has a color. Debug only doesn't. I need debug only for assert. Assert can also be on when debug code is turned off. So I have two debug macros. One is CW debug, which belongs to the libcwd library. That has to do with heavy debugging code like debug outputs. And more project specific, just the debug macro controls whether or not asserts are on, which is also a macro, but you don't really get this. It should be visible though, that somewhere I'm using that. So we have this and this. And this is defined if either is defined, to make it simpler. And here I have the CW debug only. It should have a debug only. It should be defined somewhere. Not in this file. Oh, it is here. Defined here. Oh, that's so that is defined when either. Yeah, okay. So I guess. Yeah, well, this is the CW. This is actually confusing. Maybe I should rename this one to specifically to assert something. It's something with assert, so I know it. But good, CW underscore debug being defined means that assert is on. Pretty sure about that. So if the assert is defined as assert, then this one is also defined to 1. And then likewise, if assert is defined, I mean that CW debug is defined, and then we get also debug only. So debug only is defined when assert is defined. Hence, that we need this macro. I think I'm just missing the syntax highlighting for debug only. You know what? I'm going to add it. Haha. Might as well give this a color. Okay, let's save what I did. No, not really. Let me finish what I did. I'm not sure how to close this window now. Let's just edit it. So one of these functions called this, and then Do that here as well. And then I can remove this, and the FIXME is gone. Yay! That was what it was all about, wasn't it? And now maybe this is a little bit in the middle, so let's just move this one to above it. Compiler can inline it if it wants to. And then you have to add it to the header as a declaration. It's a new thing. Let's also put it above the add stuff. Add texture. Now, since this is more or less an internal function, because we're only calling it from these two, so it should not be a public function. It should be a private function. Let's put it somewhere else. Then more private-ish. Do I have private somewhere? Yeah, private. These are functions. Yeah, okay. I have push constants, and then we have nothing else. Okay, let's put it here. Still private. This is shader resource. Okay, let me add a header around it as well then. Welcome to the family. Shader resources. Okay, so that should then all work. Yep. We can just write it, and then the other window it's still left. Can write this one as well, I guess. Can just quit it. Cannot quit it. Gotta be kidding me. Okay, whatever. Write it as well. So we added this function, and then replaced those two code blocks with it. Added the declaration somewhere here, and I changed the comment, and that's it. Looks good. Well, I was going to add syntax highlighting. Now, don't think I know how to do that, even though I wrote it myself. So I'm just going to repositories. Now I'm going to my syntax highlighting repository here. And then I should have done a lot of readmes here to explain to me how to do it. Looks like syntax C++ maybe, this one. Well, it's just a readme, right? I don't know. I think I need to... it loads things from repo base. So God knows how this works. I think I just have everything in a Git repository somewhere on my hard disk, and that is used directly, but I don't think I know where it is. However, I do know that my NeoVim is in config, I suppose, or if not, then something else. In Vim. That was correct. And now we go to syntax or colors. Try colors. Well, that points to my GitHub thing. Okay, so now I can just go to there. And I should be able to change it here. And I need a file that contains syntax highlighting like CW debug only, right? Would be nice if I printed the file name as well and the line number. It appears twice, line 15 and 16, but it's the same file, so let's open it. I guess that this is it, CW debug macros, and then there's a regular expression in it. Among which, this one. Okay, so why is this red? Always scary. It looks like it is wrong. Okay, this starts with anything but a word. So it's pretty safe, I think, to just add this without it doubling. And then again here. Oh, I made more changes here. Oh no, I didn't push it. Poor other people who are using my stuffs. So we have this, git commit all fixes and add highlighting for the debug only, was it? Yeah. What? Rejected. Remote contains work that you have not locally. It gets worse and worse. Weirder and weirder, rather. How is that possible? I must have a twin somewhere in the world who is pushed to it. Changes to README. Well, maybe I did that on GitHub itself. So now it should just work. So if I open this file again, we go to debug only. Oh, where did I see that thing? Here, right? Yep, there it is. And now it has a color. Hello, chat and streamer. Yeah, PR. That's good PR. Yeah, so if anyone else is on Linux and using NeoVim and using a Truecaller terminal, then you can also have these colors by using my repository, which I just showed. Well, I guess you can read the URL from what I just showed. Let's make sure it still compiles after this color change. Okay, that's interesting. What does backseat coding mean? Because you're the second one that says it within 8 minutes time span. PR, you haven't seen anything yet. Stick around and you'll faint or something, probably later on. Anyway, that still works. FIXME. Getting shorter. It's getting shorter. So I'm not doing this one. Yeah, these are pretty annoying, but I'll do it next. Let's not skip it. It's also the same functions, add texture and add uniform buffer. To both functions I'm passing two vectors with the same objects, set key preference. And they are not being used at the moment. They are printed and even used in a comment. I'm using this one, if it's empty or not. But yeah. Let's implement it. I think that the other one, being add uniform buffer, is even simpler, isn't it? It's also FIXME. It doesn't do the if. This one is really not using this. Neither this one, I think. Or is it? Nope, not used at all. I'm not sure anymore why I did this. I had big plans for it, I'm pretty sure. But I think that maybe, well, was a bit too far-fetched. Nevertheless, let's see if I can do something with it. At the very least, somehow remove the FIXME. Deleting it completely would be a big decision. I think that the key is already correct. Key should be assigned to the current shader resource. Let's say textures. We have a handful of shader resources, but I'm currently only using and supporting textures and uniform buffers. And the user calls this, the user of the Vulkan engine, to register a certain object. Or just create an object in their window class, and then they have to call this function. So to let the Vulkan engine know that they have a uniform buffer or a texture. And then each of those, well, they get an integer to be recognized with, which is the set key. That is, they belong to a set. Shader resource is something that is read by the shaders of a pipeline. And that means that the pipeline must know about it, and that it knows about it through descriptor sets. So eventually this shader resource must be added to a descriptor set, and that descriptor set then we must be able to communicate about it. So I'm giving it a name. Instead of a name, I just give it a number, which is the set key. And I'm just giving unique key to every object. So if the user calls add uniform buffer 5 times and add texture twice, then I will have 7 different set keys. While it is definitely possible that the same shader resource is put in the same set. Otherwise, if it were just all unique, then we would just have a single shader resource in every set. And then the whole word set would not be very correct. Nevertheless, that's the idea here. So a set key is an object which contains a utils unique ID. So this is from my utils Git repository. That makes it easy to generate thread-safe unique IDs, which is just a size type. You'll pass the type to it. That doesn't contain anything else. I mean, the static thing is just in a global namespace. Well, not in global namespace, but in as it's called, outside the object anyway. And this is not there when we are compiling without debug. So the only thing really that is in this object is this size type. And then we have the constructors and accessor and compare it and print it and whatever. So calling this creates a new unique ID. So you don't want to do that twice for the same thing. But neither the add uniform buffer must be called twice. So for each uniform buffer, we're going to call, or the user is going to call this function exactly once, and then calling this, creating a set key, I mean, will give us a unique ID. Okay, I was wrong. It's not created here. It's just getting the set key from the uniform buffer. So apparently that was already the set key was already created when the uniform buffer was created. I'm constantly saying wrong things, so it's completely normal. Don't worry about it. Yeah. Let's say with the set key. This is a shader resource base, so the base class of all the shader resources, which is an accessor for the descriptor set key. Which is stored here as a member. Gotta be kidding it. It's initialized from the constructor. Okay. Well, it doesn't really matter anyway. Unique. Then we are going to call or create or get or whatever the set index hint. Yeah, the story for that is that's not unique. This is more like things that have the same set index hint should go into the same set. The way this is written currently, I would say it's just using a new set index hint for every call. Shader resource set key to set index hint. Since the key is unique, whatever index hint I come up with, we can map, right? So then later I can find back, if I just have the set key, I can find back the set index hint, because we store that here. And a map. I think that's the only one, and the type is the set key to set index hint, whatever that is. Oh, this is a whole object. Okay, but at least that has a standard map inside it that maps a set key to a set index hint. And we are calling on it one of these functions. It's called try and place set index hint, and try and place set index hint. This is returning void, and this one is returning a set index hint. Okay. In this case, we are only passing a key, a single key. So that would be this function, which indeed returns a set index hint. And the comment says generate a new set index hint. Now, the comment says you are only allowed to add each unique key once here. So you come with a new key, and it's totally new. We just generated it. We just made, well, it didn't generate it, but it's unique for this object in a function that is only called once for that object, etc. So we come here for each set key at most once, and then it's put in this map with the value next set index hint. And after we did that, the next set index hint is incremented. And the value that is stored, that is returned. So yeah, if you only call this function, then every set index hint is going to be new. We begin with 0. So the first time we call this function, it will return 0. And then the 0 is incremented. So the next time we call it, it will return 1. And then it return 2, etc. That is for each set key to set index hint instance. And that even works for arbitrary values of set key. They must be all unique, but God knows, maybe the first time we call it it has a value of 100 and we return 0. And then we call it with 101 maybe, and then we return 1. And so on. So we start, this object here returns 0. If it, for the first time we call try and place set index hint on this object. Most likely we're only calling this function here, nowhere else. Except of course in the other add. Well, this is add texture and this is add uniform buffer. Add uniform buffer simply returns a new set index hint for every call. Add texture, however, calls another one. It that passes 2 values. So that's the other one. This one. So we already know the key in this case. This one returns, this one returns a set index hint, and here we already know it. We tell it which set index hint we want to use. In other words, it's not using mnext set index hint, it's just using the set index hint that you pass. And it's not incrementing it either here. This will just allow us to find back that set index hint using this key. And again, the keys are always unique, so that's not a problem. It's now a unique key to a set index hint, where set index hints might be used, reused. So maybe the keys are, say, 100, 101, 102, 103, and 105, and the set index hints that are mapped are 0, 0, 1, 1, 2. If you get what I mean. But the code is wrong. Oh well, wrong. What I really want is to use this. And these describe two things: preferred descriptor sets and undesirable descriptor sets. So there's already information about the descriptor set that we want to go into. Stored in these objects. Set key preference, which contains a set key. Well, that's highly annoying. Highly annoying. I would think that this really has to be a set key hint. Or not. Well, it's living its own life, maybe. Let's see where we came from. I don't think the engine likes to be told what the set key is. It only likes to be told the set key hint. The only thing that matters is that you want it to be in the same set, not which particular value it must have. I mean, even if we do what we do here, namely exactly use oh no, we don't use it. We don't use it at all. But even if you would, then it's going to completely ignore the value. It's just going to put say the resources in the same descriptor set when they have the same set index hint. Anyway, I mean, so someone is calling add texture. Let's have a look who's doing that. Well, I know that it's from here, window.h. To add a uniform buffer. Give me a second. What the heck is this? You know, there's a theory about quantum mechanics that something could just appear out of absolutely nowhere. It is possible. Well, I think that just happened. Okay, it's clean again. No idea where that came from, but I removed it. So we have this is being called, and then this is being passed, which is described as okay, I'm making here the top set key preference using the m top buffer dot descriptor set key. I guess then that's not a hint, but it's just a key. Yep, it's just a key, but that's just what set key preference uses. Yeah, that is not what I want really. This is what I want, I think. So it's stored in base.h. That has a set key stored. Okay, and that is set when the thing is constructed. Also a set key. What we are passing here is the set key context instance. Which is a singleton. I don't. Adrin. I'm just trying to. I wrote it, but now I'm trying to figure out again what I wrote or how it worked. I keep forgetting everything what I wrote. It's annoying. Well, the syntax is easy. I mean, you can just see what it says. I must say I'm slightly confused here what happens. The base class is passed and the instance of a set key context, correct? The singleton. But this is taking just a set key. So apparently we're converting set key contexts to set keys, or I'm missing something. Yeah, that this does not convert to a set key. Only get ID, that's the only thing that it has. Base set key contact instance and debug name. That is really weird. Okay, well, set index is taking the context, of course. Of course, yeah. I'm an idiot as usual. So the context being passed to the set key, and that then is doing something with it, namely this. That calls get ID, yeah, on the context. Also unique ID. So apparently we have keys within a certain context, but since this context is a singleton, there is only one context, meaning that every key in the whole program belongs to this context and gets a unique ID from this context here. Every time you call get ID. And because we're calling get ID here on unique ID context, which is defined here. And every time you call get ID, it increments the next ID thing. So we get another value every time. Which means that every set key is unique. Well, not if you look at it like this. It really depends on what context you pass. But since we're passing what the hell, man? Set key. Yeah, okay. All in all, I don't think this makes sense. This simply puts every uniform buffer in a different set, which is only correct for the test case that I have. But in general, I would say, why not put multiple uniform buffers in a single descriptor set? So, what are we doing here? This kind of, let's say that my test application is the user code, the user of the Vulkan engine. And this is the Vulkan engine. This Vulkan engine enforces something that is only suitable for that test case. So no. Well, it enforces that every uniform buffer uses a different descriptor set. That's what I understand of this code. Now base is also a base class of textures, and I know for a fact that my texture is in the same descriptor set as one of the uniform buffers. So you gotta wonder what I'm passing to the base class of the texture. Let's have a look at that. So here's the texture. Holy moly, the same set context is being passed. How is that even possible? Now I am stumped. Okay, let's see what the descriptor set key is that is being passed to each construction. The first call has MID1. The second call has 0. The second call has 1, and then 2, and then 3, and then 4. And I think that's all of it. Yep. Well, that's what I was reading from the code, but I know for a fact that this is not happening. So, very strange. I mean, this could be the key. Maybe this is the key and I'm just missing something completely. The set key should be unique, so that the set key should be generated somewhere. Is this a set key? And did I just get horribly confused? It says set key, yeah. I must be horribly confused. I think I'm very close to being senile. Set key. Descriptor set. Okay, this is set key. Yeah, I wasn't looking for set keys. Damn it. I'm looking for set indexes. Okay, so each thing has a set key. Yeah, that's unique. Okay. I'm afraid I have to start over. Add texture is being called here. No, not really. Add texture is being called here. We get the key. That is unique. I was interested in the set index hint. If the preferred set the, sorry, oh yeah, right, and now I remember. We're looking at what this thing is called. So maybe that's why I got confused, and maybe that what is happening, what I'm doing is not working indeed, but I'm not using these vectors. So it doesn't matter if it passes nonsense. Also, even this is, you know, very, very dubious. If the preferred descriptor set is not empty, it uses as a hint, well, the first one. It gets the fucking key. Yep, I'm finally seeing it. I am so stupid. I don't understand why I have 75 viewers, really. Unbelievable stupid. Makes me depressed almost. This is a key. Keys are unique. Hello. Set key preference. I kept confusing the key and the index for some reason. We have one key, or we have an index, or we have an index hint. That's three things that we have. Keys are always unique. Hints should just be compared equal or not, and indexes are the real descriptor set indexes. Hence, this is just getting the key. So it's just a unique identifier for top buffer. So what this says is that we want to use the same set index as the top buffer. And we want that stamping our feet on the floor, 1.0. That's a chance, so 100% of the time we want that to be true. But it's not using set indexes or set index hints at all. It's just using the key to refer to the top buffer. So this is the 100% sure top preference, and also one for the left. And then we're using those things as follows. First I add the top buffer. And then we add the left buffer, saying that it should definitely not be the same index as the top buffer. And here, well, if the pipeline is the other one, we first add the left buffer and then we add the top buffer, saying that it should absolutely not be the same as the left buffer. So top and left get into this different sets, but we're not using set indexes or set index hints at all. And then we say the bottom buffer must be the uniform buffer, that is the bottom buffer, must be not in top and also not in left. So now all three uniform buffers are in a different descriptor set. And then finally we say that the sample texture must be in the same one as the key. Right, okay. Finally I'm back on track to what I was thinking here and doing, and now I have to implement it. Yeah, so the only thing we get are keys. So I'm assigning a key here, and now we can run over this list, preferred things, and then if we find something that matches, then we have to use the same set index int as that was using. So suppose the first time we get here, everything is new, and we just generated the set index int for our own key, correct? This is our key. We're using our key here, and is being used to add it to this map. So I can find back the index hint using this key. How am I doing that? How would I do that? Share the resource set key to set index int. Sounds very much what I want. That is this object. It has this map, and I just want to call get set index int on it. Yep. Problem. What if I call this function and the key wasn't added yet? And this assert is going to fire. Can also call it directly. So ignoring the assert for now, I can do I can run over preferred descriptor sets. You can use auto, but I don't like auto because then often you don't know what the type is. So it probably should use auto only when you just don't know the type. Or when it is very trivial. And it's going to be const reference. So this runs over all the set key preferences. And then I can get a set key. I really was so confused. I saw this and I just read set index. Horrible. Hello. TikTok. Set key preference. Descriptor set key. Well, Yup ohm is the first. Yeah, there can be all kinds of problems here, right? Like, I mean, inconsistencies. For example, if there's no inconsistency, then I could stop as soon as I see something that has a likeliness of 1, because then we insist. But I think that if we insist, it's not good enough. If we insist but it is not possible, I think we should assert. For example, if there are 2 possibilities that both have preference of 1, it's called preference, right? Of course, it's called preference. Well, type is called preference. So I just use the default constructor. It will give me a set key that has a dummy ID. And then this is not set. mdebug ID is false. Oops. This one. Should be able to set it later then, but how? That's a good question. Maybe by assignment from another set key. Assignment, it's not shown here, but the compiler is generating it anyway. So this would use the default constructor. Now I have the I keep forgetting words as well. What is the word? Yes. Well, I'll let you use the word habit, but it's definitely not the word that I was looking for. This is using the default constructor. This is also using the default constructor. And I started to use this to indicate that it's basically undefined. So if I see this, then I read it often as whatever the value is after constructing it like this, it's not really value. But it's exactly the case in this case. Now, if set key preference is empty, then we are not going to find a highest preference because there are none. So that's a special case that I have to take into account. In that case, the highest preference, what should I do then? I think just create a new one. So that's basically what it's doing already. I can start with this anyway, because this is what we always have to do. Generate a unique set key for this shader resource. And this line was creating a brand new set index hint. Yeah, because we call this function and only pass a key. Let's delete the FIXME already. This is going to print what we came up with in the end. And then this is what we want to do if there's nothing else. So maybe I should do something like also undefined. Now, set index int is an index. Of that I already know that if you default constructor, it's literally undefined, as in set to undefined means, or undefined means that the value is, underlying value is -1, which cannot be an index. Although also here I could use this, but yeah, well. Seeing that it is an index, I would read it as literally as undefined value anyway. And then if this thing here is this vector is not empty, we do this. We're going to have more code because we also have to look at the undesirable descriptor sets. So let's just, we do something and then maybe or maybe not, this is defined, right? So it's literally undefined, and if this thing is empty, we do not do this, so it will still be undefined when we get here. And then I'll just simply end with if the value is still undefined. Did I have an in is undefined? Probably not. Then we do this. Which creates a new one. Now then, what was it called? I just looked at it. Just is defined. Just undefined. Yeah. Not is. Maybe I should rename it because I'm starting to keep typing is undefined. It's probably better. Then I have to change a lot of source code, but okay, that's not a problem. I think if is defined is better, and I probably should rename it everywhere. Right, so this works. We make an undefined value, then we try to assign it, and if that fails, then it's still undefined here, and then we create a new one, and then we print it. Okay, now if preferred descriptor set is not empty, then we're going to find the highest preference, and there should always be one highest preference because now it's not empty. Now here we get the preference. So we should also remember, I think, the current highest preference in float value. This is not really the highest preference, but I don't know. Let's call current. So I have a float highest preference with no preference at all. And then this is on the highest preference key. Set key, highest preference, whatever. So an undefined key with a preference of 0. Now we're going to run over this all the elements, and then if I see a preference that is larger than the current highest preference, then we're going to use it. As in the current highest preference becomes preference. And the set key becomes the, oh, this is nonsensical what I have here. Now you could wonder, you know, why would I do this? And why not just use this call both here and there? And I agree that will result in exactly the same assembly code. Because the compiler can look inside this function. Because it is defined in the header. So this preference here is defined here. It's in the header. So at this point we just know what it is, and it is that float inside this object. So it's just going to read the memory value of this local variable. It's read something from the stack, and then it's going to use that here on there from a register. And if you call the function twice, it's exactly the same thing. So then why would I prefer this? Well, I don't know, it's like, you know, step by step, doing things in small steps. We get the set key and we get the preference. from this set key preference. So we take it apart. This is like, it has a set key and it has a preference. It's a pair of two things. And we get that separately because we need to do stuff with it. I need to separately use it. However, the downside might be that if you don't read all of the code and you just here on this line, you think, yeah, that's nice, but maybe it's going to change the preference. So first it reads it, but now we have it in a separate variable. So maybe the preference, this preference is going to be changed and then reused later. So if you scroll down and then finally you get to this line, you don't know anymore if this preference is the same as that one or if it was changed somewhere in between. So if you're scared about that, then in cases like this, you could make it const. So this tells me immediately, like, really, these are just aliases for whatever I read here. And I'm going to use them again below. This code is so small that I guess it doesn't really matter. But once you get used to that, you know, well, let's put a const here because I'm not going to change it, and it makes a little bit more clear why I'm using a variable. Well, not really a variable, it's const. Okay, having that, we have now the current highest preference and the corresponding set key. But what if we find a new preference that is 1.0 and it is already, we already have 1.0? Now the new preference can never be larger, of course, than that. But well, there's two options. Either we make it larger than or equal, so that if the new preference was 1.0, yeah, why not? Okay. So if the preference is equal to 1, then it is required, and we cannot have two different ones that are both required. But I don't know, it feels a bit strange maybe to have an to replace value within the last one. Well, it doesn't really matter, I guess. This whole thing is so heuristic. It's so fuzzy that probably no code is going to make any sense. The only thing I can do is just make sure it is nonsense. Point being that I doesn't feel right, you know. That's using the equal sign here. I'm looking for the highest preference. So if I have something that is larger, it must replace it. But if it's equal, then whatever. So maybe I should do here a continue. Continue. And then if we get here, we must assert that preference is unequal 1, I mean. because if we get here and it is 1.0, even make that a float, although I bet the compiler is going to make it a float anyway. Well, I'm not even sure. But yeah, it's a constant. So if you compare a constant directly with a float, why would it store a double? Why 1 0? Why not 3 zeros? Looks much better. 4. Let's try it like this. So if the preference is equal to 1, but it was not larger than the highest preference, then we have a contradiction, right? Well, this is not true, because theoretically they could map to the same set index. Why would you even want to remember the key, right? The only thing I'm interested in is the set index hint. So I'm going to store this, keep track of it at least. And we get that from this map. Now I could just call a function directly, a member function of the shader input, what was get, I think. Set key hint. Nope. Okay. Let's find it back. What had the same name as this object, I think. Get set index hint. I thought that's what I typed. Get set, yeah, that's a key again. There. Get set index hint. Passing the key. So if we find a certain shader resource with this key that has a higher preference, then we get the set index hint that it was using. We want to be the same. We found our buddy. Okay, and we find 2 with a preference of 1, that's not possible. So I think this way we find the one with the highest preference. Yeah, but it's more complex. We have another input, undesirable descriptor sets. Yeah. Well, I guess that if something is undesirable, suppose there are no duplicates, so it's either preferred or undesirable. And you could kind of read the undesirable ones as negative values then, and the preferred ones as positive values, and then we find the highest preference. So you can add any undesirable stuff you want. It doesn't really matter at all, because well, maybe, yeah, well, I think this is a tiny little bit undesirable. And then there is one that is a little bit preferred, and we definitely want the preferred one. We always want preferred over any undesirable one. So we can completely ignore the undesirable values unless I know it's not true what I'm saying, but okay. I have to admit that one of the big problems with this design is that I have no idea what I want, really. I don't know, at some point I figured out that my subconscious, my intuition told me pretty much in the beginning of writing all this code, and that is like a month ago now, that I would need this, or that it would be very nice to have, or something like that. So yeah, I don't know what I really want. It's more like keeping the road open for very intelligent shifting around of shader resources in the descriptor sets. So maybe kind of a load balancing idea, I guess. So if the application is running, then you get a feel for what would be an optimal distribution of the shader resources over descriptor sets. And I thought that if then I could just work with statistics and without having to do the exact calculations, then that would be easier for the future me. So let's say we already run a few frames and things kind of stable out, and the result is are these preferences. Just as a given. I don't know where it comes from, but I assume that, you know, that it's a good indication of what would be optimal. And then now I have to write a code that then implements it. Is this how you write preferred? Apparently it is. Right, so how is Rust better than C++? I mean, if it disallows you to do something, it's not better. I want to have full control over what I'm doing. And I think C++ already gives me full control, so how is Rust giving me more control? Or if they just did, you know, they just took C++ and then made a few changes, like they changed the braces into square brackets or something like that, and now they called it the new language. That would be horrible. I would never be able to get used to that. I see so many people, I must say, well, so many, so it's a bit, but I see people say in chat here or on IRC that, oh, Rust is better, Rust is better. I have never seen one single argument. It's only, quote, it is better, end quote. And no reasons whatsoever. So I still have no idea what the difference is. Why would it be better? Why is it better? So, Samu, you're the same as me. You hear people talk about the hype. I mean, I'm older. I've been through the hype of Java and the hype of C# and the hype of a few other languages. And every time it's like all the companies suddenly want to use that because then they are hip. Look, my company is hiring programmers of the latest language. We must be good. Until the hype is over, and it turns out that the whole language was not very good. Or at least not better. I mean, one thing is for sure, Rust is the new hype. So you hear a lot of positive things about it. But that's just a hype. And since I have not heard one single argument, like I said, with actual facts in it that explain to me what would be better, I'm like, yeah, right. So I'm not even going to look at it. I mean, if you look at my own libraries, right? So what I base this code on, what I wrote I mean, this contains code up to 20 years old, but it's mostly 10 years old, or written in the last 12 years, I should say. So if you look at EVIO, that is my event-driven input-output library, it is different from anything that exists. There is no other library that can do full duplex over a socket input and output at the same time using O streams and dynamic buffers that use no copying at all. You just read it into memory and then that's where it is decoded. It is maximum fast. And then I have stateful task, which I started, oh God, this is really way back. It's a method of, it's a way of coding, really, more paradigm almost. So instead of using threads, I'm using tasks. And no doubt other people have overtaken me, and now there are other libraries that have tasks. But the idea is basically it comes down of coroutines, and coroutines came much later than I worked on this, but it's comparable with it in the paradigm thing. Like you write tasks that can run to a certain point and then return to the thread pool and then later continue at the point where they left off. But I designed this from scratch. I didn't learn it from a professor or read it on a website or learned it from a book. No, I've just been coding and coding for decades, and from experience I just started to see a certain pattern and a certain need for something that didn't exist. That's why I wrote it. Thread safe also, I have not seen it anywhere. My approach to doing locking. So this allows you to wrap any class or struct in a way that you cannot access it anymore, unless you take a read lock or a write lock. And it works with templates, so you can you pass a policy rather. So you can lock it with a normal mutex, or you can lock it with a read-write lock or a spin lock or whatever lock you want. And then you can you create an object that gives you access, and creating that object also locks it, read or write lock. And especially the read-write lock support is powerful. For example, you can have a function. There's just some documentation. I'll close it, or this poor website gets nuts that I download that picture all the time, which is 4 megabytes. I want to let's go to my repositories again. This one. So what we do is say I have a struct foo, then I make a foo type, which is then a wrapper in the namespace AI thread safe around this foo with a policy. And this policy is using read-write locking, and using AI read-write mutex as the underlying read-write lock thing. Then you can create it. And there's a thread safe in the sense that nobody can access it. The only way to access it is to create a WAT, which stands for write access type, which is the subtype of the foo type now. So you create a foo type write access type, or you create a foo type read access type. At the moment you create it, it locks the underlying log. So you take the read log or the write log, and at the same time it gives access. So if you have the write access, you can use the arrow operator here from the write access type, and then you get a non-const pointer to the foo. So you get a foo pointer from this. So you can call a member function, for example, called write access that is non-const. You can also pass it to a function. Like here, if you have a function f, which takes a, well, it's not a read access type, but a const read access type. It's almost the same as a read access type, except that you cannot convert this read access type to a write access type. That allows you to pass something that is created from a const foo type. So if you have a foo type that is const, you can get the read access on it, but you can then only get the cread on it. And therefore you cannot convert the const foo later on to a write access type. If you get what I mean. So if you really only need read access, the function should accept the cread. So having that, you already have access to const members. This returns a foo const pointer. Now say we have a function that takes a reference to a foo type, so now it's not const. Then you can take the write access type. And it is also allowed to pass a WAT type to f. So f was taking a cread, but you can simply pass a WAT. That works with inheritance. The cread is the base class of the red, which is the base class of the WAT. So if you pass this, it's simply you're just passing it so that this is the reference to the base class of the that's fast. That's put it that way. So there's no multiple inheritance, so basically this reference is equal to that. So there's no assembly code involved at all. You can just pass a write access type to this function. Now here we have an example of a function that takes a read access type. And then suppose you do here some code that only requires read access and maybe sometimes return from the function, or often return from the function, and only sometimes you need a write access type. Then you can take the write access type from the read access type, and that does it without releasing the read log. It's not like it's going to release the read log and then take the write log. No, it's seamless converts the read log into a write log. So it's not possible that some other thread gets the write log in between. And then after that you have the write access. And then the last example is suppose you have a function that takes a foo type. You take the read access here, and then you call h, which takes a read access type. Now it is possible, if you convert from a read access to a write access, that you get a deadlock. Say two different threads both have a read access and they both want to convert that read access to a write access. Well, you cannot write lock something when another thread has a read lock. So in this case they would cross lock, say thread A has a read lock and thread B has the read lock. Then thread A wants to get the write lock, but it cannot because B has the read lock. And B wants to get the write lock, but it cannot because A has the read lock. So both wait till the other one releases the read lock before they can get the write lock. So that's a deadlock. So what happens if you try that, then the first one blocks. So thread A would say, okay, I cannot get this write log because B has the read log. And then the second one, that would be B in this example, would say, okay, I cannot get the write log because A has the write log, but A is also trying to convert this to a write log. And so am I. So we would deadlock, and therefore B will throw an exception. Therefore, if you want to do something like this, and we cannot do it here because you have to release the read log, right? This function takes the read log. So we have a try catch in the function that calls this one, which takes the read access type, so that we can jump back all the way to outside the scope where we took the read log. So for the same threads, say A is hanging here, trying to get the write log, and thread B comes here, thread B already has the read log. It calls H, it comes here, throws an exception, exception is caught, then thread B calls read to write yield. That then, we are already outside this scope now, so thread B has released the read log. And at the moment it calls this, it will wait here until the other thread, that was the reason that it was throwing an exception, did get the write log. So as soon as then thread A gets the write log, then we continue here, you come back here, continue, and we try to get the read log again. So now thread B will hang on getting the read log because thread A has the write log. Then when thread A leaves this scope, releasing the write log, then B can try again. B gets again the read log, and it has to do all the stuff again because, yeah, it just had to wait its turn, including getting the read log. This way of coding, I've seen it nowhere. It's completely my idea. And it is super, super, super handy, really. I'm hardly ever using mutexes again. I'm using this. And so, yeah, so I've had many of these things written. I made a few tasks on top of my stateful task. So I wrote the task that does DNS resolving, socket handling, XCB in this case, which is also using socket, of course, and resolving, I guess. Oh, no, XCB is not resolving things. And I have an XML RPC task, dbus task, so to communicate with dbus. And all of these tasks have in common that sometimes there's a moment they have to wait, mostly for I/O. And then instead of doing a system call to that takes 50 microseconds, I just return to the thread pool and let one single let stateful task library basically handle the scheduling of that, which is user space and therefore much faster than using normal scheduler. I would say if you're a C++ coder, you really have to try out these things, because I'm convinced that I have something here and that more people should be using it. At the very least, a thread safe thing, and yeah, if you're brave, then you can even you call that, dip your toes in the stateful task thing. The problem with this one is that there's a little bit not enough documentation. So you would have to look at examples that I wrote. And using tasks is easy. But it is especially powerful. You can write extremely complex things and still understand it and get it right. And that without these tasks, you would not be able to get right. It would be buggy and not working all the time and stuff like that. hard to be maintained. And it really brings the complexity that you can write to a new level. However, writing a task is quite involved. It is not easy. Every time I want a new task, it's really, 2 weeks, and then you have a new task. So it's like building blocks. I'm writing slowly new tasks, and then eventually I should get to a point where I have all those building blocks where I can do most things already. I also have a new task in this project, so in the Vulkan engine. I guess it is derived publicly from stateful task. So my pipeline factory is a task, pipeline cache is a task. I have an async task, and I have a synchronous task. A synchronous task is a task that is executed synchronously with the window. So the window is synchronous, and then you can start a task that is run in synchronously with the window. That it is basically thread safe to not lock. It's just being executed by an engine that is being run in, say, the idle time of the render loop. So if at some point I get to the end of the render loop, and then say I have my number of frames are limited to 60 per second, and that only took 10 milliseconds to get around to the new frame, then I have a few milliseconds to do nothing, because I have to wait till the 160 seconds is passed. So that would be idle time in the render loop, and then at that moment it will execute tasks that are synchronous tasks. Sometimes you just need to do something where you are absolutely sure that things that are being done as a part of the render loop are not running, right? If that doesn't matter, you can create an asynchronous task, which is just run whenever there's a thread available in the thread pool. Thought I had a more complex task here somewhere. I don't see it pop up, so maybe that was derived from async or synchronous task. Yeah, this is a pretty complex thing. So I have an immediate submit task. The idea is that you construct all the information needed to do an immediate submit, which means a small command buffer that you want to run on the GPU. Let's say small as in just a little program that you want to be executed on the GPU, and you have to think about something like copying a buffer from the CPU to the GPU, doing a few barriers to synchronize stuff. Then I can just create a new immediate submit task, and then pass on what I want to be done, and then it will do it for me. I think it's being used by this one. This is a queue. So I can have multiple things that I want to be executed on the GPU, and then put it in the queue. Probably this one uses that one, not the other way around. I don't know. But it gets really hairy very quickly, as you can see. Let's have a look at this one. So this one is derived from Vulkan utils task to task DQ, which takes the persistent async task, which is one step further than async, as a parameter, which is then used as a base class, and it takes an immediate submit request. It's the type. So task to task is DQ, sorry, is a thing that allows me to pass stuff which I call datum, the singular of data, from one task to another. So say one task requires information that is gotten by another task, then that other task will run until it got the information that is required, and then put it in this DQ, so that the requesting task can read it. So if I look at the immediate submit queue implementation, so this is then a task with ASCII art documentation. Oh, that was already the thing, sorry, I missed it. So the implementation is done in the multiplex implementation. And we have, each task has a number of states that you can define. This one has only two, actually only one, and done, and doesn't do anything. Like, just calls finish to signal that it's done. So you would almost think, why would I write a task when it is only having a single state, doesn't halt anywhere? Well, maybe it has a loop, so it just exits, but it waits and then enters the same task, the same state again once it starts running again. Yeah, I know my memory has degraded a lot, but I'm afraid it's not possible anymore for me to explain this. I remember vaguely that it was pretty difficult. It is doing difficult stuff, but now it has evaporated again. This is really an important reason for me to write bug-free code, so I never have to look at it again. This just works. So I never have to look at it again. I'm kind of, the task-to-task DQ interface must be used somewhere. See if we can find that back. Don't see it. Maybe in one of the other functions that is being called here. It's a nice colors, Timon. Okay, enough bubbling. What was I doing? I'm forgetting like crazy, Boss Bunny. If I don't see someone for a year, then I'm usually totally forgot them. I cannot remember my own youth. It seems to be a strange thing. Maybe it has to do with the fact that I cannot see visually. So I close my eyes, it's black. I cannot imagine any pictures at all. There's a name for it even, I recently learned in the last half year or something. They called it aphantasia, so I think it was. Let me try to find that back. So not aphantasia. Accept everything. Mental imagery as a research topic was considered taboo in the second half of the 20th century. Anyway, here, aphantasia is often described as a visual condition, but it's actually multisensory. People who experience a lack of mental imagery can have a reduced capacity to access other mental senses. Imagining sound, I cannot imagine. People can imagine sound. I wish I could. I have only very, very seldom. I'm only, I cannot consciously imagine sound. A few times, very few times in my life, I managed to do it. Mostly, around sleeping time. I was able to hear a concert. So a classical concert in my head, everything, just composed it myself. It sounded really nice, so nice that I really wanted to do it again, but I just can't. It has to do with sleep, I'm sure. I dream in pictures. And I've noticed that when I'm really on the edge of sleeping, then I start to see images. Movement. I have a spatial insight that is off the scale, of the paper, of the margin of the paper. They tested that when I was 12, and when you scored really high, they would draw it in the margin outside of the graph. But in my case, that was not possible because I even went off the paper. That was funny. And it is also funny that I have this super high spatial insight without having any visual imagination. I just know where things are in my head. I can think about multi-dimensional spaces without seeing anything in front of me. I mean, thank God, seeing is really limited to 3D. And I think I use that by coding also. I used to, when I was still a genius. I'm not now. Now I'm an old senile. But yeah. I'm somehow aware of a multi-dimensional space of a linear differential equations. Basically, it's just program is something that has many links. Everything hangs together. I cannot I cannot translate it to words. I don't think in words, by the way, normally. So I'm getting more and more trouble with formulating sentences because I keep not thinking in words, and then I have to construct the sentences as a kind of a translation of what I'm thinking. And yeah, it's difficult at times, especially when you cannot remember a certain word. Okay, so that was the word, aphantasia. And now I do not know anymore why I mentioned it. Bugs Bunny, that would be interesting, yes. Yeah, I have a few life stories, that a few things I still remember because I retold them several times during my life. And then I kind of remember the fact that I repeated it. So one of those stories was that it was known when I was a teenager, I think, maybe late teens, that I had this big spatial insight. And my brother had a girlfriend, and he wanted to brag basically about my spatial insight. So when he brought his girlfriend home, he had a puzzle that they had been breaking their heads over, and they couldn't do it. So he sat on the table and he said, well, let Carlo do it. And then the question is, you have basically the inner tire of a bicycle with just a hole in it, with the what is that in English? Ventiel? Should probably know it. At least I know the Dutch word. Valve, yeah, of course. Is Volvo also the right thing for a bicycle? I think so. So you take off the valve, then you have a little hole, and then the bicycle tire is infinitely stretchable. You can stretch it no matter what. And then the bicycle, so the tire had yellow is black, and it had yellow rings around it. So, like this. So this is the tire. You see my mouse, and then around so is yellow here, and yellow here, and yellow here, like that. And then the question was to turn the tire inside out through the valve in your head, and then tell them how it looked like. So I did that, and I told them, and they were satisfied. Yeah. Funny. I'm pretty sure I can imagine a tesseract. Isn't that the right word? Tesseract. Yeah, one of these things. I wanted to see it. There's a better one. A bit simplistic. You need to see it animated, I think, before you have any idea what we're talking about. No, not that. Tesseract band. Come on. Tesseract. So I wrote it correctly. Animation. There is one. Yeah. Jump. So it's pretty symmetrical. I mean, it's just 8 points. Yeah, so this is 4 dimensions, so you have 4 axes, and then you have each axis has an outer point on it. So you have 8 outer points on all the axes. You have also 8 points when you draw the tesseract using say binary values for the coordinates. Well, let's say the cube is 0, 0, 0. Shut up. Yeah, 4-dimensional cube, tesseract. Yeah, but say cube would have coordinates like this. The first one being the z coordinate, and the second one the y coordinate, and the third one the x coordinate, because this is 0 and this is x is 1. And then this is 0 for y, and y is 1, and then you could draw one on top of this with the first coordinate 1, which is then, say, the top layer with z is 1. So you have in total 8 points here, 2 to the power 3. And then for a tesseract, you just have 4 coordinates, so you get it again times 2. You have 16 coordinates. I once made a puzzle. I was a member of a certain society, and I made the puzzles in their monthly magazine, and I got a 100% score, which I thought was simply because I was very dedicated. I would just not give up until I solved it, no matter how much time I had to put into it. And then once you did a lot of them, you want to keep that score. So I was motivated as well. On the other hand, I have to say, yeah, well, that's exactly what I mean. So I don't think those puzzles were very difficult. They just required to be persistent and motivated to solve them. And at some point I went to a meeting, and then someone came to me and he read my name on the badge on my cloth, and he said, "Oh, are you Carlo?" Oh, and he was all like bowing down almost. What is the word? Because I was that guy that had a 100% score for the puzzles, and that really irritated me. Like, I felt I did not deserve that at all. It was like I just explained. I just put more time into it. I was motivated to do it, but the puzzles were not difficult. So I felt, what's the word? I felt, I did not deserve it, and that made me feel bad, and I blamed this guy for making me feel like that. And not just him, but everyone who would think that it was special. So I thought, I'm going to get him. I'm going to send in a puzzle that is difficult, yeah, just to show when something is difficult. So I made this puzzle, and I sent it in to the magazine, and nobody could solve it except one guy who turned out to be a mathematician, and that basically used higher mathematics to solve it. While really it was just a visual spatial problem in infinite dimensions. If anyone's interested, and yeah, I'll just tell the puzzle, I guess, if I can still remember it. Yeah, now I think about it, it's kind of involved, but okay. So the idea is you have n-dimensional hyperspheres. So that would be, you have an n-dimensional space, Cartesian space, and then you take all the points, you take a middle point, and then all the points that are at the same distance. Let's say the radius is 1. So all the points at a distance 1 in that n-dimensional space, that forms an n-dimensional hyperspace, right? Now, you can put those at grid coordinates in an n-dimensional space, where, say, you have the n-dimensional space filled with n-dimensional hypercubes. Well, that would be simple if you just, you know, putting blocks on top of each other, but then in n directions. Let's say you make think of cubes, if you want, in 3D, cubes of a side with 2, so 2 by 2 by 2. Fill whole space with it. Then the middle point of those cubes, are clear what they are. You can put the spheres then with the middle point at the same place as the middle point of those cubes. And then, of course, the sphere will touch the sides of the cubes in 6 positions, left and right, 2 for each axis. And then if you fill each cube, if you put a sphere in each cube, then the spheres will exactly touch each other. So I call that, say, and then in n dimensions, of course. I mean, that was for 3 dimensions. You can do it in n dimensions. So I did it in Dutch, and I have to translate it to English. So I call that the grid positioning of the spheres. Say. And then the spheres will take a certain volume fraction of that. Now you can also rearrange the spheres so that they take a maximum volume fraction, and then there is a ratio going for in n dimensions, going from the grid positioning to the most dense positioning is a certain factor. And then the question was, let's call that the compression ratio, okay, for dimension n. And then the question is, what is the compression ratio for n plus 1 divided by the compression ratio of n, dimension n, for n goes to infinity. And I guess that the problem there is that basically I'm asking you to imagine infinite number of dimensions, because the question is to do it in your head without using mathematics. So I never found anyone who could do that, but I spoke with a lot of people who are all, say, university level or higher, but absolutely everyone could follow the reasoning. So say we were just walking outside and they had given up after a few weeks or whatever. And then I would explain to them how my thought process was. And I would just talk, while we're walking outside, say. And I would explain them how to think about this problem and then find the answer. And 100% of the people could understand it. Yeah. I think I still think it's more or less easy. I can do it in my head, but I have definitely more problems with finding the English word. So if I have to explain it, you hear how I'm talking. It goes with trouble sometimes. It would be a lot better if I just put my words on paper basically, or typed it in, and then rearranged it and thought about it and rewrote it and let someone else fix the grammar and then read it out loud, and then suddenly I would sound like a smart guy maybe. If I'm doing a live stream like this and have to explain what I'm thinking, it must sound like an idiot, I think, because often I just don't know what to say. But yeah, I've always definitely preferred multi-dimensional problems. There was this other problem. I think it was interesting. It was a puzzle that you could get. It was a puzzle of carton. Is that paper? Say thick paper, stiff thick paper. Is that carton in Dutch? I don't know, man. And it had 24 pieces, and they were all squares, and you would have to put them in a rectangle of, I guess, 4 by 6. So 24, must be 24. Each square has 4 sides, of course, and they were colored out of a palette of 3 colors: yellow, red, and blue, I guess. That was, and then each square was different, even under rotation. So you had all the different permutations of all those possible squares. Let's go. There is only 24 of them, so we can I can just do that. So say I have a square, not like that. Oops. I'm insulting you guys now, because I have no idea why I draw this, except for people that otherwise cannot follow it. So this is one of the squares, and then they were filled in with a color in like a triangle. So this, if this side is red, then really we had a triangle here, and unfortunately I cannot draw that, but so there's a line from one corner to the other, and another one here, so you get 4 triangles, right? Triangle here, 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 and here, and then those triangles were given a color. So this could be red, say, and this could be red, this side, and then this side could be yellow, say, and this side could be blue. Okay, so you had and this big triangle here was red because those 2 little triangles are both red, and then this triangle here is yellow and this is blue. But we can do that better, of course. I can just do clockwise or RBYR, right? So begin here and then we write BYR, but on the other hand, rotation is also allowed. So this piece is exactly the same as that piece, and it is exactly the same as this piece. Yep. So now let's find all 24 pieces, but I'm not going to use red, blue, and yellow. I'm going to use A, B, and C. So one of the squares has AA has all one color, And then of course we have that, and we have not that, because that's the same as this one. See, it's just one side is a B, and the other three are RA is equivalent. What we can do, BB is different, and even this is different, because, well, on the rotation it's still different than this one, even though it has two A's and two B's. And then we have A and three B's, and we have all B's. And now I have two colors, all the possibilities with two colors. Yep. And then we need to do add a C. So might as well do all the possibilities with three sides and two colors to make it easier. That's that. And then we put a C somewhere, like a C could be here, or the C could be here. Or the C, oops. The C could be on the other side of the B. And then here, of course, the same. The C can be, oops, on this side or on that side. And here is just one position. Doesn't matter where you put the C. And that's one C. So then we can do two C's. So I'm going to do, let's say we have AA or AB or BB, and then I must add C's. Well, I'm going to skip that. Let's do three C's, which is obviously either this or that, and then we have four C's. And there must be 24 possibilities, so this is 3 plus 6 is 9, 15, so we are lacking 9 of them. Okay, so we have CC, and we have ACAC, and we have the same here. Oops. CBC and CCB already have 9. I would be missing one now. I think it is. This one is asymmetrical. It has a mirror image. Well, this one too. Uh-oh. Do I get too many now? That's nonsense. If I rotate this one, we get that. And I already have that here. This one too. I should put A first, so I get, let's say if I rotate this, we get the BC at the end. Sure, I should already have that one. Yeah, there. Yes, I'm single. Okay, so anyway, there's 24 permutations like this. And then the question was to put them in a rectangle of 4 by 6, such that all the sides that touch each other are the same color. And the outside of the whole rectangle is then also a single color. And that was an interesting puzzle, but I thought we can make it more difficult by making this more dimensions. So you can think of, say, for step 1, you make cubes, which have 6 sides, and then you can color those out of a palette of 3 colors, or maybe 4 colors, or no, how many colors you want, such that a nice solution is possible. So for example, if you take a certain amount of colors for cubes, then you end up with a prime number of possible permutations. So that's not going to be very interesting or impossible at all if you want the outside to be the same color. So the question is there for 3 dimensions a possible number of colors, except one color, that allows you to put all the permutations such that the only sides with the same color touch each other, and the outside is also the same color. And if not, what about 4 dimensions, or 5, or 6, or 7, or 8, and so on? Find the lowest number of dimensions plus some number of colors, such that you can make a cube that is not, really, well, not a cube, it's going to be a block, but I don't want a single side to be very much smaller than another side. It's probably not even possible. And in order to solve that, you need to solve the sub-problem, how many permutations do exist. So now we have an n-dimensional hypercube, colored out of the 2n outsides are then being colored out of a palette of k colors. And the question is, how many permutations do exist? And this took me a while, I think 2 weeks. There is not a simple question. And at some point I got a certain insight. You need an insight. I got the insight while I was biking. So you can get the insight without pen and paper. But yeah, only then I could solve it. You must see this. You must recognize this. And then you can solve it. Otherwise you cannot solve it. So it's a really interesting puzzle. Pretty difficult, I think. So I'll formulate it again. So how many different permutations exist when coloring an n-dimensional hypercube out of a palette of k colors. So I made this a long time ago, this problem. I'm going to put it in Google. I never put it in Google before, because it would be no fun if there is already someone else who would put it on the net somewhere in the meantime. Coloring the faces of a hypercube. Uh-oh. I think I want to have the word permutations in it for sure. Otherwise we're missing something. Gonna look at this one, what it is. about dots. Yeah, that doesn't really seem related, does it? It's about the pose set. Corner pose set with an application to an n-dimensional hypercube stacking puzzle. This is only about 2-color hypercubes, apparently, so it's definitely not going to give a formula for k-colors then. Yeah, just this is a different problem. Well, okay, I'm going to say that we cannot find it, at least not quickly. So I'm doing real math here, no pictures. I think it's also not related. Okay, I think we have a good puzzle here. As you cannot find the answer on or maybe you can, but it's, I don't know. Hypercube pictorial user, what is this? C++, what is it? Windows. Yeah, right. Something else. Okay, so anyone interested in my puzzle? There's it. How many different permutations exist when calling an n-dimensional hypercube out of a palette of k-colors? I'm afraid that it's not really high school math. But, well, if you fail on the math, that's no problem. You can still come up with basic the basic idea behind it, I think. So the insight that you need. But you need to be able to think about multiple higher dimensions. Otherwise, you'll not be able to find it. So only considering 2 and 3 dimensions is not enough. It's 10 past midnight. I think I'm gonna stop the stream. I really wish I could make some progress with this thing here. It's probably a good idea to think about this first before I stream again anyway. So that's a good thing, then I can go for a walk or I can fall asleep with it. We now have a problem to think about. Yeah, it's a nice problem to think about. So I'm going to stop the stream and then hopefully next time I'll have something more concrete plan on what is actually needed to do this. Good night. Thank you for keeping me company, peoples, and success with your own coding.